Today, we will be combining Snake and Breakout into a single game. We will take the ball from Breakout and use it as the food for Snake, while also using the snake as the paddle for Breakout. First, let's create our assets. We will need a ball, brick, snake, and a border. The assets will be based off a 64 by 64 grid size. The ball and the snake will both be 64 by 64, the brick 128 by 64, and the border 3072 by 1728. You'll also want to export all of your files to the same location, for they are easier to access once we are inside of our project. Now that our assets are created, let's start a new project. I'll call mine Snake Breakout YouTube. You'll then want to change your template to 2D and turn off your analytics. Now that the project is open, go ahead and create a new folder and name it Graphics. Then go and drag in all the graphics we just created into the new folder. We'll then create a new sprite and name it Border. Drag your border asset into the sprite location of the new sprite. Then check your settings to make sure that Alpha is transparent is turned on. After aligning the border to the camera, we'll then create a new sprite and name it Snake. Drag your snake asset into the sprite location, then add a rigid body 2D and a box collider 2D. We will then add a new script and name it Move. Open up the new script and go ahead and erase everything. We'll then make a new bool called canMove to determine when the tick of the movement should occur within our fixed update. We will also need a variable called direction, which is a vector2, to return the direction that our character should currently be moving in. Then also create a rigid body 2D to cache the rigid body 2D of our controller. Now we will need a list of transforms to store all of the tails of our snake as it grows longer. We will also add in a public variable to hold the tail prefab that will be spawned in each time a new tail piece is added. Now we will add in a vector2 last position to store the position our snake was in before it moved to its new position. This will be so our tail knows where it needs to move to. We will now add in a read-only float to hold in the size of our objects, a way to make it easier to work with our grid later on. Go ahead and re-add your start function in, and this is where we will cache the rigid body 2D component into the variable that we created. Next, we will add in a fixed update function. In this function, it will control the actual movement of our character. The reason we do it within a fixed update is to keep our physics within sync of what you can see on the actual screen. Within this fixed update function, we will store the current position inside of the last position vector we created earlier. We will also make a new vector2 called newPosition, and we will use a future function called getGridPoint to return a point on a grid that last position is closest to. Now let's create the getGridPoint function. It will return a vector2 and input a vector2. Using the inputted vector2, we will create another vector2 called result. Result will be point plus direction times size. We will then take the x and y of result and divide it by the size of the grid. Then we will round the x and the y to its nearest int and multiply it by the size of the grid. This will always make sure that our next movement position is a position that is on the grid, regardless of if we got knocked a little out of sync on a previous frame or not. We will now access the rigid body of this component and use movePosition to move the position to the new position of the grid point that we just created. We will now create an update function, and within this update function we'll control the input the controller is using. We will be using WASD and the arrow keys to determine the movement direction. We will take the input and return it into the direction vector we created earlier based off the button we are currently pressing down. We'll now create a counter int to hold the amount of time that has passed between each tick within our fixed update. Each tick of the fixed update will increase the counter by +1, and each time it reaches a threshold, it will turn canMove to true and reset the counter back to 0, allowing 1 tick of movement for our snake. You'll then want to encapsulate the movement within an if variable for canMove, and then after the movement, reset canMove to false. Let's test this to make sure that it worked. Our snake is constantly falling downwards because the gravity scale of the rigid body component is still set to 1. But instead of just turning it to 0, we're actually going to change the body type from dynamic to kinematic. And there we go, it works. We'll now create the onCollisionEnter2D function for determining when the snake comes in contact with the ball. So go ahead and compare the tag to make sure that it is equal to ball, and if it is, we will set the tail prefab's transform.position to the last position. This ensures that you don't see a skip between the object after it instantiates onto the screen. Now instantiate the object and get the rigid body component of that object and move its position to the last position. This makes sure that the physics engine is also aware of the position that it is spawning in at. Then also make sure to add your newly instantiated tail to our list of tails that we created earlier. Now back up in the fixed update function, we'll want to check and see, does our snake currently have any tails? And if it does have any tails, we'll want to also make sure they move along with our snake. Now instead of moving each section of the snake every single movement, we'll actually just grab the last tail in the list of tails and move it to the position the head was in before it moved towards its new position. To do this, we will be using system.link to grab the last object of our list and move it to the first position of our list. Now that we've created our tails on contact with the ball, we'll actually need to add a ball to our scene. So go back to your project, and after it compiles, we'll add a new sprite and call it ball. On this new sprite, we'll go into our graphics and drag the ball sprite into the sprite location. We'll then add a rigid body 2D and a circle collider 2D to our new object. You'll also want to create a new physics material 2D for our ball to make sure that it can bounce when interacting with objects. Just turn the friction to 0 and the bounciness to 1. Let's test this. Oh yeah, we still need a edge collider for our border, so go back to your border and add a edge collider 2D. You'll then want to make sure your edge collider has a bit of a radius so your ball will not easily pass through it. Then just go into the editor and drag it to your edges to make sure it fits appropriately for your project. And there we go, it seems to be working now. We'll now want to create a new prefab object for our tail, so create a new sprite and call it tail. You'll then want to add a rigid body 2D to the tail. Now, take the snake sprite and put it into the sprite location before adding the box collider 2D. Now drag your tail prefab into your project to create an actual prefab. Then delete the tail object inside the hierarchy, then click on your snake and make sure to drag the tail prefab into the tail prefab location on our movement script. It may also be useful if we go to our ball and actually change the tag to ball. It seems we've also forgotten to switch the body type from dynamic to kinematic on our tail prefab also, so let's do that now. And there we go, it seems to be working much better. Let's go ahead and add in a quick key down to grow our tail so we don't have to hunt down the ball every time we want to test out our tail growth mechanic. Alright, it seems we got that working. So I believe the next thing we can work on is adding in the actual wrapping movement for our snake so that when we go off screen, we'll just reappear on the other side of the screen. The first thing we're going to do is grab the Unity3D of our snake and disable it. This way our collision will not get in the way as our object is moving from one side of the screen to the other side of the screen. We'll also want to check on the snake tail component that we will be moving to do the same thing. So just go ahead and disable both of those before doing any of the movement. Now after we move our object to its new position, we will do a check to see if the object is outside of the border of our map. The easiest way to do this is to go into your package manager and go to all packages and then show preview packages. We'll be using the Pro Grids package to help with this to keep everything in alignment without us struggling. Go ahead and change your grid size of the Pro Grids package to 0.64. We will then drag our snake head to the left side of the screen to see at what point it looks like it should loop back over to the other side of the screen. So if our x is less than -14.08, we will move our x position to 14.08. We will now do the same thing for the Y position of the object. For the Y, it will be if it is greater than 7.68, we will move it to -7.68. And if it is less than -7.68, we will move it back up to 7.68. Now we will put a else statement on the end of if can move to determine if it is a tick where the movement should not be happening. And if that is true, we will take the collider 2Ds of the snake and the tail component that moved, which is now the first in the list of tails and not the last, and re-enable their colliders. Let's now test this to make sure that it worked. We'll go ahead and reset our snake and ball transforms back to 0, then move our ball to the right a little bit just to make sure things aren't in the way. Now let's click play and see if it works. Okay, it seems like we have a problem. Let's go take a look at our code. It seems we just need to replace our greater than sign to a less than sign. Or vice versa, I mean. Let's grow our tail out a few links and see if the wrapping is working. And it looks like it is working. Let's now select our ball game object and add a new script to it called ball. Within this script, we will add a new variable called RB. RB will be a rigid body 2D. And now within start, we will cache the rigid body on our component into the variable RB. Now moving on to the fixed update, we will take the velocity of the rigid body and use a vector2.clamp magnitude to ensure that our velocity does not increase over our set max velocity. Then, in the function onCollisionEnterTwoD, we will compare the tag of the collided object to see if it is a brick. If it is a brick, we will set the collision object to false. We will also make an if statement to see if we should increase the velocity of our ball when it bounces on something. The way we will determine this is by taking a velocity buffer and subtracting it from the max velocity of our object and seeing if our rigid body's velocity magnitude is less than this value. If it is less than this value, we will take the velocity and multiply it by itself plus another 1.15, which equals out to 15%. Let's now create our brick sprite. So create a new 2D sprite, name it brick, and then in our sprite spot in the sprite renderer, drag your brick asset into it. Move your brick to the top left-hand corner and then duplicate it across until you're all the way across to the other side of the screen. Then grab that full selection and duplicate it down 2 more times. If we then go ahead and enter play mode, we can see that the game is already working. It seems the ball sometimes likes to go into our snake, so we can take a look at some of our settings and see if there's anything we can do to try and fix this. If you look at the collision detection of the rigid body 2D, you can see that it is set to discrete. If we switch this to continuous, it will have a better collision detection when interacting with objects. Now we will be adding in the snake eating itself to die, and also we will use the bricks as another form of object that the snake is not allowed to collide with. We'll simply use an if statement to compare the tag of the collided object to see if it is a brick or a tail. If it is a brick or a tail, we will set our snake's direction to 0. We will also set the active state of this game object to false. Then we will enable the canvas, which will hold our button for resetting the current scene that we are on. So back in your project, go to your tail prefab to create the new tag that we have just set within code. We will simply call this tag tail. Make sure to set the tag of your tail prefab to the tail tag that we just created. Then in your hierarchy, right-click and create a new canvas, and on this canvas we will create a button. But first, let's create an empty game object and name it bricks to store all of our bricks, just to clean the hierarchy up a bit. Once you add your button to the canvas, go to the text of the button and change it to be reset. We will then add a new script to our button called Level Manager. Once you add the script, go ahead and double click it to open it. And we will add in a new function for resetting the scene. We'll call this function reset level. You will also need to add in the using statement unityengine.sceneManagement. Once done, we'll go into our reset level function and add in the line scenemanager.loadGame and parentheses scenemanager.getActiveScene and .name. Close parentheses. Then back in our project, we'll add a new onClick function to our button and drag in our level manager script, and then drop down the drop down button and select reset level from your level manager script. We'll then go into our move.cs script, and on the start function we will add in canvas.enabled equals false to make sure our canvas is not showing during gameplay. It seems when a new tail is added to our list now, the collision between the tail and the head are interacting without it seeming like they're touching, but because of the fact that both colliders are 0.64 by 0.64, their edges are actually just slightly touching. So if we just go into the tail prefab component and reduce the size of our box collider 2D, this should solve our problem. Let's go ahead and re-enter play mode and grow our tail out and see if it works. And it seems like it does.